All right, so I'm here with, why don't you give an introduction to yourself?
My name is Oren Eini. I'm also known as Eini. Uh, I deal mostly with databases, mostly building them. I have a blog at eini.com, and that's the two sentences into it.
Okay, and I think I mentioned this to people this morning that you think you now have the record for having the longest commute to come to Twin Cities Code Camp because you came all the way from Israel. You
Yes.
said that's, 6,800 miles?
Yeah.
About that? Okay.
Yeah.
That's quite the trip. And thank you to Judah for, because was he actually working for you when he was over there?
He was in Israel for a month, and he was working for us at the time.
Okay.
He even brought his family over, and I think they had a good time.
Yeah, saw him do a lot of pictures on Facebook and stuff,
Yes.
and doing all tours around all the sites and stuff in Israel. So you're doing two talks that basically are around the product that you have been working on for
Yes.
quite some time now, which is RavenDB.
Yes.
Okay. One question that I've always wanted to ask is, you're building RavenDB using .NET, and some people always have the notion of a managed language as garbage collection and the stuff just can't produce an extremely fast, high transactional system. Yet you're doing that.
Yeah, so the counter example, even if we discount RavenDB and 5+ years in production, that disprove that you have Cassandra, Hadoop, most of the big data system written in managed languages, Java. With building a database in managed language isn't easy. One of the things that you have to understand is that you, as a database, are you really going to control memory, allocations? I want to have a really good control about when do I do garbage collection. And some of the things are challenging. For example, I would have dearly loved to be able to manage my own heap. So I can just, there's a lot of processes you run, generate a lot of memory. Indexing is a good example of that.
Okay.
And when they're done, everything they generate is garbage. Throw it away. If I had manual control over that, it would be drastically simple. But even so, using managed language still gives you all of the advantages of managed code. So simplicity, better error handling. You don't have to think so much about a lot of the stuff. If you look at the unmanaged systems, so a lot of them tends to be much smaller, much simpler. We're talking about LMDB, we're talking about LevelDB, HyperDex, those sort of things. Even if you talk about RookDB from Facebook, those are much smaller systems that focus on doing just one thing, mostly because trying to do those sort of things in unmanaged language means that you have to carry a lot of baggage with you, and that's create much higher complexity. So there's a lot of expertise that you need to know. Okay, how do I make sure that I don't generate too much garbage? How do I make sure that my memory allocation is within reasonable bounds? How do I control compute bound operation, that sort of things? But in the end, a lot of the things that it comes down to with writing database are algorithms, IO management, and the way that you actually execute the queries. Another thing that is very important is that when you're running on managed language, especially on the .NET or the JVM, then you have quite a lot of additional libraries and facilities available for you. For example, if I want to do my indexing system in RavenDB is based on C.
Okay.
So a lot of that, already there already exists done. Now you have some stuff like that in the unmanaged land. So you have Silucine as a good example. The problem here is that okay, great, you have Silucine, but a lot of the other stuff, okay, how do we do things like host a web server? How do I integrate with a monitoring tool? Those sort of things. All of those things exist. They're just much harder to work with. So yeah, we've been doing that for years and years now, and I think that was a really good decision.
Okay. When you're developing Raven, I'm guessing you probably have to use some fairly advanced tools to make sure that you're doing all the things that you just mentioned as best you can. What would you say are some of the tools that, for example, if a developer needs to do something that you have to that would be considered a fairly advanced application? What are some tools that you've used to find those types of things to improve on performance?
So let's split this into several things.
Okay.
Let's talk for a second about what happened when you actually have a production system and it exhibits some problem, high CPU, high memory, slow response, and that sort of things. At that point, you need to resolve that as quickly as possible with as little interruption in service in the least intrusive way possible. So in order to do that, in RavenDB specifically, we started adding something we call debugging points. And that's basically things like, okay, show me the internal queue status in the system. Let us force garbage collection now. In the trio version of RavenDB, we got to the point where you go to the management studio and you hit a button, and at that point what you see is that we go into the system, we gather all of the available inputs that we have, up to and including getting a stack trace of everything that is happening right now. Mm-hmm. And then we can display all of that information for you in a visual fashion. So you say, okay, I see that the reason that we are slow, we are doing high-level suggestions here, and here we are stuck on iron, that sort of things. A lot of the issues that we run into on a regular basis actually relates to what are we actually doing? Mm-hmm. And most of the time we have to deal with, in production you have a black box system. So we explicitly add features directly around that. For example, if you're running on a cloud system, so if you're running on your own data center, this is a database. Database is the king of the data center.
Yeah.
So they get the best hardware, the best I/O, the dedicated people, and that's wonderful. And then you go to the cloud, and when you're running on the cloud, you basically get the shittiest thing that you could possibly get away with. Yeah. And people expect, I have a database and it's supposed to run there. We have a customer, and that he had a problem about slow response times from RavenDB. And we look at that and we says, okay, that's interesting. And we gave him a tool to run. And the tool is, this is now going to be part of a RavenDB trio in a few weeks. And that will basically measure the disk I/O when we run certain operations.
Okay.
And what we found out is that reading an 8 kilobyte part of the page could cost up to 30 seconds on this machine.
30 seconds?
30 seconds, yes.
Wow.
Now, he was trying to get a result of about 40 megabytes or so.
Okay.
So sometimes it relates to how the cloud manage certain operations. In this case, he was using attached storage, and that means it was on the network. That means that you sometimes hit the network spike. And if the disk is going to give me a very slow I/O, there is very little I can do about it normally.
Yeah.
So at that point, we actually have code now in RavenDB to actually detect scenarios like that and improve on that. And we trade memory for time and all sorts of stuff like that.
Okay.
So that's what happened in production and how you troubleshoot things. And a lot of that was done explicitly because we get a support call, we want to be able to resolve it as quickly, as efficiently as possible.
Right.
The second part is what happened when actually developing things. And that's what things get interesting. Because when you're talking about optimizations, then the question is optimization to what end? For example, I can optimize myself for high throughput scenario. We actually have dedicated API for that, and that means that when you start throwing, 50 million records at RavenDB, we have a good way of handling that.
Okay.
The problem is what happens when you start talking, okay, no, I don't care about the high throughput scenario. I care about constant throughput. So instead of trying to put 50 million records as quickly as possible, you say, okay, I have a 30 writes per second.
Okay.
And now, if you do the math, 30 writes per second comes to about 2 million writes a day. So theoretically speaking, we are talking about a situation that is much easier than the 50 million writes. But the problem with that is that on the 50 million writes, it's expected that I will only deal with that.
Okay.
On the 30 requests per second, 30 writes per second scenario, I have to deal with that and all of the other requests as well. And then you have, okay, what happens if I have a read-only or read-mostly scenarios? What happens if I need to do index? So that's just the different scenarios. And the main problem that we have is if you give me specific scenario, it's very easy to optimize for that scenario.
Yeah.
The hard part is, okay, how do we optimize for that scenario and all the others and all the other ones as well. So a lot of the things that we're doing, we actually optimize for specific scenarios. We have different strategies that handle how to do that. And we switch between them on runtime.
Oh, okay.
And when we talk about switching to runtime, I'm saying, okay, let's say that you start writing to RavenDB constantly. 30 requests per second. Then it says, okay, given that this is the best allocation of resources that I'm going to need to do that. So we're going to effectively create a low throughput, low latency system in that scenario. Then you have the nightly process that writing 100,000 records to RavenDB. And at that point it says, okay, if we use the strategy that works for 30 writes per second, it will take us 2 hours to process this. And so instead we're going to switch to a high latency, high throughput. So it has different implications about how things are going, what's the effect, but we can do that on the fly. And after your batch process is over, then you're back to 30 requests per second, and we shift back to the other strategy.
Okay.
So all of that happens on the fly and without requiring any sort of involvement from the admin. One of the things that we're trying to do is say, okay, RavenDB is a NoSQL system. We have customers. We have customers that run many nodes on multiple data centers, and you can't actually have a system like that that is designed to have a babysitter on board. So if you're talking about, okay, let's run SQL Server or Oracle, then for the high-end systems, system, you have usually a team of people dedicated just babysitting the system, just making sure that okay, let's tweak this configuration parameter, this configuration parameter, that's what it is. With RavenDB, we don't have configuration parameter, we have a configuration range. So we tell you, okay, this value should be able to move between this end and this end. So, and use your own heuristics to figure out what's going on. And a lot of the time what we're doing is we're constantly improving the kind of heuristics that we have. For example, with the cloud example, we now have heuristics to handle high latency I/O from the cloud line, stuff like that.
Okay.
Another thing, finally, just about the development system itself, the good thing about using a managed system is that you also have all of the managed tooling. So that means that we can just be at the profiler and see, okay, here are the hotspots.
Yeah.
And that's just beautiful.
Yeah. Well, I want to say this before we're done, just so I can get this up here. this is the product. All right, it's Raven DB. I really like the logo. It's really cool. So, thanks again for coming all the way out. I appreciate it. Are we done?